Welcome everyone to this. I think it is the last seminar before the holidays on the Northern Hemisphere. And today we have invited Gauti Asbjörnsson to present his, I guess, latest research topic. And the story about Gauti is quite interesting. The background, not about, well, I will come to Gauti, but I will talk about the project first. It all started in April 2010. Malcolm invited me to come to South Africa to look at some crushers. And I went to site up in Limpopo, and they were not running in a steady state condition. And when we looked at the plant, we concluded that everything was very non-steady state. We went to the Comminution conference in April, and all of you that were on that conference, you remember that there was this Icelandic ash cloud. The volcano that I can't pronounce was spewing out ash. And me and my group, we got the message from Lufthansa, no problem, sir, we'll put you on the next available plane. And that was 8 days later. So we were very bored at the nice Vineyard Hotel. I couldn't live with that sliding doors, you know, and so we moved to Camps Bay. And we were staying at the boutique hotel. We were laying on the floor, me and Erik Hultén, with Post-its, and we were mapping out what then later the same year became this a project on dynamic simulations. We had no idea how to solve it. We were not sure it was possible at all, but we saw the potential in doing plant dynamics in contrast to steady state operation. It was an Icelandic ash cloud. Then we got the money granted from Swedish aggregate producers and construction fund, and we started to look for potential applicants, PhD students. And then we already knew Gauti, and the interesting thing here is the Icelandic ash cloud resulted in an Icelandic PhD student. So I don't know if you have any secret method to control those volcanoes, Gauti. Gauti did a really good work during 5 years, presented his PhD thesis, Crushing Plant Dynamics, in 2015, then continued to work as a postdoc for the group. And just recently, he was awarded, what would we call it, the permanent position at the university, as and also got granted the docent title, which is basically a double degree or a second doctor's degree, but you show that you can do research on your own. So it's basically another thesis, and it's evaluated by an international scientific committee. He has also been evaluated on the teaching capabilities. So then to get this full position, perpetual permit, what is it called? Perpetual. You are evaluated, and for the scientific work, you get the docent degree. So that's where we are now. And the latest finding is Gauti has expanded his dynamic simulation capability into environmental simulations. And I thought that would be interesting for this group of people to listen to. I think it will come in minerals processing and mining. And we are eager to hear more about that, Gauti. So with that, I think it's time for you to enter the floor. So please, the floor is yours.
Thank you, Magnus, for this nice introduction. Let me just share my screen. Go into presentation mode. So I guess, yes. So you can see my presentation now?
Yes, we can.
Oh, good. So yeah, the topic of the presentation today is the integration of environmental impacts into the process evaluation. And as Magnus said that in the introduction, I did my dissertation in 2015. And one of the aspects that I discussed in my future work was the possibilities to integrate environmental indicators or KPIs into the simulation to get more details into the process evaluation, not only the mass flow or kind of the stability of the circuit, but also kind of what impacts it has on the surrounding societies or surrounding environment. Trying to change slide. Yeah. So yeah. So this is Isaac. This is my oldest boy. He's actually turning 4 years today. And what is interesting is that when he will be graduated as an engineer in the future, he will be graduating around the time of 2045, which is quite interesting because with the Agenda 2030 is that internationally by 2050, we are supposed to have solved the climate crisis. And Sweden, they want to have done that by 2045. So when he becomes an engineer, we have already solved the problem that we are facing today. So he will get kind of an easy way of working as an engineer. Isaac is a fairly regular 4-year-old boy, weighs about 15 kilos. His main interests are excavators and trains, no surprise there. And in his hand, he holds a particular aggregate. So it's a more or less a fraction that is 16 to 35 millimeters, 32 millimeters. And it has a certain CE marking that is applicable for this application. So sometimes I ask this question, so how long does it take Isaac to consume his own weight in gravel as an average Swede? And this would be much easier if we were in the auditorium, but I'll give you the answer directly. And that is 15 hours. So even though he's a small contribution to society, he still needs to get to kindergarten, visit his grandma. He's using the infrastructure, he's living in a building. And as an average Swede, we are basically consuming about 1 kilo of material each hour. So, and we in Sweden, we are not that different from other European countries. We are more or less on kind of place 10 or 11 in how much aggregates we are actually producing on a yearly basis. And given that we are 10 million people in Sweden producing 100 million tons, it's approximately 10 tons per person per year. Going down to, if we kind of break that down into an hour level, then it's 1 kilo per hour. Most of it is crushed rock. And there's a small fraction of sand and gravel and manufactured aggregate as well. So we are in a quite similar situation as Turkey, for example. So most of the aggregates that we are using and producing, they are from crushed rock with small fraction of natural sand. And the natural sand is getting less and less used because we need to use that for the filtration of the groundwater. So it's kind of the focus of that is getting increased continuously, and the increasing taxes of natural sand to kind of limit the use of natural sand. So, and in Sweden, we have an abundance of high quality virgin material. So that's why we have that situation as it is here. And and most of it goes into ground constructions. Some of it are used in concrete production as well as asphalt production. And as I mentioned, the majority of the aggregates that we are producing in Sweden, they come from virgin material. But if you look into kind of the environmental impact, and I'm going to be jumping a little bit between indicators, and we'll be mostly talking about the CO2 equivalent or global warming potential or greenhouse gas emission. But these are all referring to quite a similar thing. So this is an overview of kind of the impact that different metals and minerals have from a CO2 equivalent per year perspective. And this is a study, environmental evaluation of metals and minerals production based on life cycle assessment approach. But when I looked at this, I saw that they don't include aggregates. And usually when you are looking into aggregates per ton produced material, the impact is fairly low compared to, well, minerals, because there's an additional processing that is needed, and so that kind of contributes to the average value. But with the sheer amount of aggregates that we're using, and for 2023, there's a prediction that we will be using around 47.5 billion metric tons worldwide for aggregates. And if we assume that we have kind of an average emission between 3 and 6 kilograms CO2 per ton, then we actually get 1.5 to 3 in the power of times 10 in the power 8 tons CO2 equivalent per year. And that actually puts this quite high here up in the scale. And that's mostly due to the sheer amount of aggregates that we need to produce to maintain and develop our infrastructure. So, as I mentioned, the Agenda 2030, we should all be aware of that. And the main goal there is that we achieve net zero CO2 emission by 2050. And there are some variations there. As I mentioned, Sweden, we aim to reach this by 2045. Why, I'm not sure, but they might want to be a little bit ahead of the curve. And also, we have national incentives. This is from the Swedish Aggregate Producers Association. They, in 2019, they created a roadmap of their efforts to reach net zero by 2045. Sorry. And this is kind of how they aim to prioritize their efforts in the coming years. So currently they are focusing on the electrification. So it started in 2019, and their electrification phase is there in 6 years, and it's going to end in 2025. And we have been involved in the project there, measuring the load that mobile crushers have on the grid. And we've been looking into different renewable energy sources, battery solutions, transformers, stuff like that, mostly to simplify small producers that are relying on fossil fuel for their mobile crushers to kind of connect them to the grid, make it more economically feasible for them to connect to the grid. And then their efforts are then going to shift over to the logistics, trying to optimize that in some sense, maybe going for the electrification track as well, or finding different placements of different quarries and on the intermediate stations. And kind of in the end, they aim for digitalization between 2036 and 2045. And since we have been involved in the electrification, we thought logistics is not that much that we can contribute, actually. It's an interesting area, but it's not really our cup of tea. So we thought that we would kind of jump the curve on digitalization and kind of start focusing on that by ourselves in order to have a solution for the industry when the industry is ready for the digitalization. And most of you are a little bit familiar with what we are doing at Chalmers or Chalmers Rock Processing Systems. I mean, our background is within crushing and screening. Sorry. And as Magnus mentioned before, I've been looking into dynamic simulations since 2010, trying to find out different solutions that fits with the problem that the industry is facing. So there's been kind of these two tracks that's kind of have falling into. One is the academic side, like we are here presenting at conferences, doing journal publications, doing seminars, talking to our peers within the academia. And the other path is the industrial track, where we are interacting with the industry, finding out what problems that they have, doing the implementations, and giving them solutions that they can have for optimizing their process. But quite often, these have been kind of almost separate tracks that and I get this stuff from my own experience doing the dynamic simulations. It's difficult to hand over the models over to the industry and expect them to use the models. So it's always been this kind of a fictive wall in between that, allowing the industry to themselves explore possibilities with the models. Of course, we have cases, but and kind of the general aspect of this, there's kind of this restriction there. And what we see more and more is the kind of the external drivers, especially on the environmental side, that we are minimizing waste, we're minimizing the energy, maximizing our resource utilization, kind of getting more for less, basically. And when we're trying to find paths forwards to kind of integrate all this into one single track, we started working on our process simulator, what we named Plantsmith. So this is a screenshot of the software. So it's a modular online steady-state simulation platform. So we did not go the dynamic simulation path. Of course, that's possible. We just need to kind of create a new solver and add on the infrastructure within the system structure. But in order to have this easy step for the industry to get used to using models and getting this kind of the introduction into the possibilities that they can have with doing modeling of the circuits. So that's why we went for a steady-state simulation platform to begin with. And it's fairly easy to create your own flow sheets. So it's a drag and drop application. The front end is, as I mentioned, it's an online, so it's HTML and CSS coded with JavaScript for the functionality. And so what we are basically doing in the simulator itself is we're doing the mass and energy balance of the circuit. We have the model library, which is continuously being upgraded and extended. We have kind of a nice uploading capabilities with standardized modeling templates, making it fairly quick and easy to create new models and implement them. Everything is stored in a GitHub depository. So both the front end and the back end core code is stored in GitHub. And we have a customizable interface and also not application management, but user management. So depending on what user access you have, this can be customized depending on who is actually logging into the software. And in the end, we have an API communication capabilities, creating the possibilities to connect to external softwares and databases to include in the evaluation. So when we set up the process, we have configured all the equipments, connect them as it is. Then we press play, of course, and then we get in the user interface, we get kind of the simulation results here presented in a nice format here next to the circuit interface. What we get here is the particle size distribution. We get the specific energy of all the streams. We get the conversion for the different properties that we have in our stream, the density, the mass, the moisture, all that is included kind of in our streaming properties. So now when we had kind of the base for the process simulations, now we need to start to think about how do we include the environmental aspects, because they are quite spatial and temporal dependent where we are. So we needed to find a structured format to actually implement the environmental aspect to be correct from the start. So in 2018, we were granted funding for a pre-study. So we had started looking into the environmental aspects a little bit before that. And what we kind of converged into was the environmental product declarations. And these are standardized formats, so they are based on the standard ISO 14025. This is environmental labels, and they consider the full life cycle assessment of goods and services, or products in this case, as we have for the aggregates. And there are three main components that we are looking into. So there's all the product category rules. They are kind of defining the scope of the life cycle assessment, kind of how do we set the frames, the system boundaries, and kind of setting up the rules for doing the LCA. And then the LCA study is the backbone where we do actually the quantification of the environmental impact, assessing both kind of environmental and human health impacts. And that is then, as I say, based on the rules and guidelines that we have from the product category rules. The EPD report is then the kind of the summarization of the LCA report, as well as the interpretation of the results based on what the product that you have. And why we went for the environmental project declaration, or the EN 15804, because we saw that it was a kind of increasing trend within our field, or within the construction field at least. And here you can see kind of a little bit more the increasing specification, that's the hierarchy of the different standards, starting from the environmental labels and declaration, the what is it's based on. Then we come into the LCA, which is still a generic methodology, and then we start kind of focusing in on the EN 15804, which is then for construction products, giving us the rules and framework, as I mentioned, with the PCR, kind of how we need to set up the LCA model. And parallel to that, we have also the general program instructions. And in Sweden, we have EPD International. In Australia, it's EPD Australia, I think it is just called, and then EPD Norway in Norway. So it's well, many countries have their own program operators that are responsible a little bit for the interpretation of the standard. And kind of in the lower end is the PCR, or actually the sub PCR. As for aggregates, for example, in the EN 15804, we define the general approach for all construction products. So it's not just aggregates, it's wood, it's doors, it's windows. So everything is kind of clumped together, and how, from a general aspect, how we should do the LCA. The sub PCR goes a little bit more details into the specific components, and there is a draft in the works at UPG, the European Association for Aggregates. It should have been published last year, or even the year before that, but it's been a little bit delayed. So here you can see the system boundaries that they have defined for natural aggregates. There's a slight differentiation there when it comes to natural aggregates, or manufactured aggregates, or recycled aggregates. They have different system boundaries for the different aggregates. So these are kind of the 3 or 4 main groups that we are looking into: the A1, A2, A3, and A4. A1 referring to mostly the drilling and blasting, but within that we also include the site preparation, handling, and storing, and reclamation that is done within the year. So every time when you do an EPD, it's based on actual data for a specific year, or well, specific 12 months at least. So it can't be from June to May the year after. Then A2 is the loading and hauling from where we have a blasted material until you reach the primary. And then the A3 is the manufacturing of the aggregates itself, the crushing, screening, any additional treatments, also water recycling, water treatment. And then there might be also a little bit more internal transport within that section as well. And then the last one is the transport to external customer. And as I said, we already in 2018, we saw an increasing trend with EPDs, and they have just continued to grow. And here you can see the number of construction products that have been published, have a published EPD. So when you've done the work that is needed to create the EPD report and the LCA report, that is usually sent then to a third-party verifier that verifies that your data that you collected on site is correct, your LCA models are correct, and how you do the calculations for the EPD report are also correct. And in Sweden, as I mentioned, we have EPD International. And for aggregates in Sweden, we have now, I think we reached above 20 sites, aggregate sites that have a published EPD for their aggregate product. So and we see that when there are tools in place, then the process gets kind of speeded up. Then they don't need to rely on consultants to do the work. So it's kind of automating the process for the environmental calculations. And usually when we're looking into LCA studies of a quarry in the publication, we usually look at the life cycle of the quarry, going from exploration to extraction to processing, transport, waste management, and remediation. So this is not really the focus of the EPD to look at the complete life cycle of the quarry. So instead, we are looking into the life cycle of the aggregates instead. So, but you can still see kind of a similar trend here. They still need to extract the material, transport it, and manufacture it. So this is like the core that we are looking into the mining operation or the quarry operation. So this is usually what we are kind of focusing in on and what we can do the simulation on. But we also need to, well, the transport to customer is an optional section in the EPD for aggregates. And quite often this varies a lot, so it's difficult to determine a single distance to do the evaluation on. But what we also need to do in the EPD is look at end of life and benefits beyond the system boundaries in the end. And these are scenario-based, looking into what are the possibilities in the future when we do need to recycle the aggregates that we are looking into in a specific application. But as I mentioned, we are focusing on the extraction, transport, and manufacturing process. That's what we can actually simulate. And if we look a little bit more details into that, what we are looking into is all the consumables and the production at different stages. So looking into the A1, where we have raw material or drilling and blasting or site preparation, then we are integrating the amount of explosives that we're using over a year, the amount of diesel consumed, even electricity. The transport, we are counting for the diesel consumption and the chemicals used, also oils if there's some maintenance needed on the equipments. And in the A3, the manufacturing itself, it contains all what is consumed within the process. It's lubricants, salt, chemicals, water, rubber, metal, electricity, diesel even, if you're running a stationary or mobile unit. And what we do get out of the system is our products. So usually we are referring to product groups, not specific products. And then of course we get some waste, either mixed or hazardous or inert material. So that these all need to be accounted for when we do the estimation for a process over a year. And in the back end, for example, when we are looking into the drilling and blasting operation, especially in this case, the blasting operation, then we have in our database, we have models, LCA models for the blasting. So that accounts for, starting here, so both the explosives. So we are using Gauti from Schwera for our LCA modeling. So for the blasting, we both need explosives and foam, for example, and electrical detonators. And those need to be transported to site with a truck or kind of a similar equipment. So, and then when we're doing the blasting operation itself, we need to have a model for that as well. So all the steps needed for transporting the blasted or the explosives and the detonators to site, as well as the blasting, we need to have an LCA model for that to quantify the emissions or the compounds that are released during the different steps of the blasting and the manufacturing of the explosives. So, and as I mentioned, we have an LCA database with parameterized models. So we, in this case, we have it per kilogram explosive. So that is then scaled up if you need, well, 10 tons, 100 tons, 1,000 tons. So the emission is then just scaled up with the amount that we are actually utilizing. They are accessible through an API. So now we have then integrated the environmental aspects. So we have a standardized framework for the environmental aspects and the simulation platform. So in the background, we have the LCA data in a separate database that is that IVL is responsible for. And the IVL is the Swedish Environmental Institute. So they are professionals when it comes to environmental aspects. We have the models for the circuits, and then we have different templates, for example, for both the LCA report and the EPD report. And then we need to manually enter the amount of consumables, how much diesel, water, explosives we are using over a given period, usually a year. And then we have the technical setup for the site-specific data and the data quality, meaning that is it a measured data or estimated data, and how do we do the estimation that's determine the data quality. And as an output, we get the environmental impacts that are defined by the standard, the EN 15804, and they are about 32 impact categories. And we also generate a JSON file with the numerical data. So it's, well, the list of data basically. And as I said, we have two reports that are then generated, the LCA report and the EPD report. Both of them are needed for the verifier to verify that the data is correct and the process is correct and doing the environmental estimation. And with this, we want to kind of streamline the EPD process for the Swedish aggregate producers. That's kind of the main focus of this national project, which we are referring to as EPD BADI. So, with a system in place, there are additional capabilities that we can do with it with minor modifications, meaning that we could extract cloud data instead of entering it manually. We can connect through the additional system with an API. We can automatically send the results both to verification, so the report itself and the JSON file, and and the idea is that the files that are generated are Word files, so they can be customized by the producers. The JSON file was more or less be locked data, but it's readable, and then that can be easily transferred into machine readable files that can be used by additional systems that need the environmental aspects, for example, different BIM softwares. So this is kind of the modification that was done. So we added a additional tab within the process simulator where you kind of fill in all the information that is kind of the site specific, the production, the amount of consumables, the allocation matrix, so how you are allocating different resources onto different product groups, and then the result itself. And they are then generated into both the EPD report and the LCA report, and well, the JSON file. So it's kind of can all be generated with a click of a button. And the results that you usually get, as I mentioned, it's 32 different impact categories, and there are additional tables as well. I'm going to demonstrate a little bit later on. So this is the result that we got for the 2 reports that we got verified last year. So we were looking into a mobile crushing unit and a stationary crushing unit. So we're not going to take into all the aspects, but we're going to focus on the GVP, or the CO2 equivalent. And of course, as you can see, that when we have a mobile process, we have a higher GVP compared to a stationary process. Since they were quite similar, they were producing similar products, but of course the mobile unit was run by a diesel generator. So that's why we have a higher footprint for the different groups. And of course, the difference is smaller for the first group, meaning that we have screened it out earlier than the later product groups. So then we have the drilling and blasting and the transport causing kind of the base impact. What we also get is the contribution analysis for the different consumables. So what are the biggest contributor to different impact categories for different groups? So, and still we are focusing on the GVP, the global warming potential. And as you can see, for most of the resources that are causing the highest impact, it's diesel. Not only for the GVP, but for eutrophication and other properties. But what is interesting here is that the percentage of total impact when we have out of the way for mobile crushing compared to stationary crushing. As you can see, for the stationary crushing, the percentage of total impact is reduced as we go to a finer product. That's of course because we are replacing the diesel with the electricity. Which in Sweden we have quite low CO2 emission from our electrical grid, compared to the mobile crushing, where we're only increasing the impact of the GVP because we're adding more diesel into the system for producing the aggregates. And then the final estimation that is included in the EPD report is the sensitivity analysis. So what if we start? Well, let's say it like this: with all the assumed resources that we use, there's always some uncertainty. If was it plus minus 10% on the diesel consumption over a year? Was it something that was unaccounted for? So what is needed is that looking into different contributors to environmental impact and changing them in a systematic way to see what impact the change has on the baseline case. To see how sensitive the system is to alteration in the operation or the quantification of the resources used in the production. As you see, when we are increasing the diesel with 10%, we get the increased CO2 emission with 7%. Of course, there is the electrical consumption and the blasting also involved here. So that's why we're not getting 10% as well increase. So when we were kind of at the end of the second phase of the EPD battery, so creating the demonstrator that I've gone through with you guys now. So then we had the opportunity to join different European projects and use parts of the software in a larger system. And since we kind of designed it in the beginning to be modular, it was quite convenient to kind of integrate with external systems. So I'm going to start with the TK Quarry. We are about 2 years into the project. So that started 2 years ago, and we have still 2 years left. So here, as I mentioned before, the possibilities to integrate cloud data through an API was always kind of intended with the platform. And that's basically what we are achieving here with the Gecko Quarry, where the focus is on creating what we call an innovative quarry system, the IQS, where the aim is to combine, well, all sensors, processes, tools, methods that are within the process, adding on multiple sensors as well, of course, and have it all stored in the same location in real time in a one single system. And the aim is not only increasing efficiency and profitability, which is of course one of the core aspects, but also how do we integrate health, safety, and environment into a larger platform aimed for, well, production of aggregates. So this is kind of the structure or the system that was proposed in the beginning when we were doing the application itself. So in all, we are 25 partners, and it's a good mixture of companies, universities, and research institutes. We have 5 pilot sites within Europe, so it's a quite nice distribution of both of the type of quarries that we're looking into and the location of course. And the biggest purpose was kind of how do we maximize digitalization and automation in the aggregate sectors while still being a efficient solution to be implemented by the, well, producers. So everything is, the aim is to include everything in the software. So we have explosives, we have drilling and blasting, we have logging of mobile machinery, we have monitoring of the crushing plants, the ore properties themselves as well, control, external transport. And then on top of that, we have then the expert system communicating through this IoT platform. That is, of course, the aspects that I mentioned before, the health and safety, economically efficiency, social acceptance, and then the environmental impact, which is kind of our core focus. And then on top of that, adding AI prediction framework for the optimization of the operation. So it's a kind of ambitious task, but I think we're getting there gradually. So what they have been doing now, and it's a company called Gauti that is responsible for the platform itself. So they are responsible for the integration of all data that is generated through different parts of the operation. So we have the client here, the pilot. It can be the pilot sites or the expert system. In this case, Plantsmith, that is our software. So we communicate with the CDMP, so Central Data Management Platform. So this is where the logic of the system is. So we access through the application gateway that determines what capabilities that we have in the system and what system is available for us. Of course, when we enter the system as, well, Plantsmith, the platform, we are directly directed into the environmental data management system. And of course, when we are looking into the data and exploring the possibilities and trends, we are then in the data management tool. It's a Power BI dashboard, and that needs to extract the data from the system, the data management platform. And that extracts then both the information from the data management system as well as the plant production systems. So you can see there's the consumables and the production itself. And what the aim here is to automate as much as possible, so the operator doesn't need to tinkle with the system in any way. So it's trying to automate the system as much as possible. Yeah, that's just how we are. So the data management platform, you can see here. So it's a data storage that are kept on separate servers for the different companies. So there's no risk of data intrusion by the different companies into wrong, data. So these are kept separate at the moment. And as you can see, we have the plant production and stored in a specific location. We have the plant consumption, the real-time energy efficiency, effectiveness, and at the moment when we are still adding in the consumables, so at the moment it's done manually. As I mentioned, this is not finished, so the aim is to have it somehow automated when they get in the data of how much they have consumed, or have it even logged, especially for the diesel consumption if they have connected to the the machine itself. So that could be uploaded into the system automatically. So the plant consumption, you kind of go into the system, you go into plant consumption, and you add submit new data. Then you have a data stamp on what this is referring to, which period this is referring to, and then what is actually included in your data transfer. And then when we have all this data, both the consumption, the production, and we send out the request to Plantsmith, that's done does the calculations and sends back the JSON file. And it's this JSON file that is illustrated then in a Power BI system, as you can see here. And the purpose is not to do this every year. So we need to increase the resolution of the data to a month or weeks to be able to demonstrate trends that we have in the system over time. And then we are kind of reaching a little bit more into what is referred to as dynamic LCA, DLCA, where we are looking into the temporal perspective of the operation from an environmental point of view. So we could also include, for example, a dynamic life cycle impact, meaning that depending on which day we're operating or which hour we're operating, the grid, the electrical grid can change. So these information can also be integrated. They're not integrated at the moment, but there's of course the possibilities with the APIs to extract that data, because that data is available online. And so when we are doing the site evaluation for the 5 different quarries, we needed to create a little bit more framework for classification of what impact we actually have. This is more from a kind of an overview point of view. So looking into environmental impacts, not only the emission, but what visual impacts we have, contamination of water bodies, changes water bodies, land use, land stability, vibration, so kind of all aspects, and what parts of the operation are actually affecting our environmental impacts. And then also depending on the scale of operation, how much are they affecting our our environmental impact. So then we could, when we are approaching the quarries, we can have a more standardized framework of not only looking into the emissions, but also the overall environmental aspect of the quarries. And we were actually presenting this at the World Mining Congress this week. So when we're looking into the different sites, we have just recently done the state zero evaluation, meaning that we were looking into the year of operation before we started the project. So what is the current situation of the quarries? And they are of course varying because they have different locations, they have different operations. But as you can see, they are kind of reaching from 1.4 kilograms CO2 per ton and up to 10.6, 10.7. So there's a large variation there, of course. And hopefully at the end of the project, we can demonstrate that we're actually improving the operation, we are improving the production, not only by looking into the environmental aspect, because we're only looking into environmental aspects, we are not creating change. So with the other work packets, such as the automation work packets or new technology that is being implemented, and also one of the core is implementing renewable energy sources, installing solar panels. So how much is that gonna affect our environmental indicators? So in the end, we'll see how much improvements that we are able to make. That's going to be quite interesting. So we are about halfway into the Gigafactory, and the year after that, we were able to be involved in another European project called Rotate. It's a similar consortium, but the focus has shifted. So we are only 1 year into this project, so there's not much information or data that I can actually demonstrate from that particular project. But as the naming implies, it's the focus is circular and ecological, essential and critical raw materials. So it's not only the quarry operation, but also kind of looking into, well, mining and critical raw materials. So we have, again, 5 sites spread around Europe, and the kind of the aim there is to create a platform that is more focused on the environmental systems. So it's an environmental management system, not a large IoT platform as we're doing in the Gigafactory here. We have a specific focus. We are delivering circular solutions as one of the work packages that we're looking into. We want to decrease cutoff grade. We want to improve extraction processes, and we want to enhance social acceptance. And basically it's 3 pillars that we are relying on in this project. So it's the processing itself. So what technical improvements can we make in the process in order to kind of reach a little bit more net zero? The second pillar is the circularity aspect, and the large focus is on the waste valorization. How can we create value from our waste piles? And the third pillar, which we are mostly involved in, is the environmental footprint assessment, creating an environmental management platform. So, and they recently published in our VP1 report the generic system structure for the platform within Rotate. So, as I mentioned, this is an environmental management system or platform, and what we are looking into the project is looking into is biodiversity, mine closure, risk assessment, energy efficiency, environmental impact, and multi-criteria decision making. So when we have all that information, not only from the environmental impact, which is our focus, but biodiversity, risk assessment, energy efficiency, and how can we make decision based on these multiple criteria. And it's a similar setup, of course, as for the Gigafactory. The biggest difference here is maybe the visualization, the front end. There's not going to be a Power BI. They kind of have indicated at least that they want to develop a little bit more specific user interface. This is not based on Power BI, but we have a common data repository. We have SQL servers that's storing the data from the different plants or different solutions. And then each platform is a separate entity that you are transmitting data either in XML or JSON file. So it's a similar structure, but still different. So with this is 3 projects, the Berry, Gigafactory, and Rotate. It's been quite interesting to how we should include the environmental indicators in the planning and operation of aggregate production. So I mean, we don't know how the final solution should look like. I mean, we've gotten quite nice input from the producers, what their requirements are and needs, but it's still a kind of working process to find a way forward. But we can see it's a gain in momentum. At least in Sweden, when we started in 2018, asking the companies and getting more information on the environmental aspects. they said no one is asking for this, so why put energy on it? But now they have started calling us, is the software ready? Is the software ready? Can we use it? So the users, their users, what they are providing. Hello? No.
Sorry, it wasn't my intention. Continue, Gauti.
No worries, I'm almost finished. So each platform has a potential of providing more detailed information on the environmental impacts of different quarries and the quarry operation. If you're only looking into the manufacturing of the aggregates, or if you're looking into the drilling and blasting or the transport itself, so it can easily be divided up, of course. So, and with the model application, it opens up different opportunities for the integration of external system. And as I mentioned, we create the results in the JSON file, and we have scripts for converting that to an XML file. And when we're talking to construction companies, they are relying on BIM softwares to kind of for their planning, and they are quite often relying on generic data that's quite often not good. They want to have more specific data. That gives us the possibilities to provide them with site-specific data to increase the resolutions of their estimation of what the environmental impact that the buildings or the construction will have in the end. So that's kind of everything that I wanted to go through today, and I hope this was informative for you guys. So I'm open for question now.
Thank you very much, Gauti. We are past the hour, but we started late, so please, questions are welcome. And while we are waiting, what do you see forward for minerals processing and mining industry here, Gauti? This was quite extensive about the quarrying industry, but how can we implement this into minerals processing?
I mean, it's of course quite similar aspects. So I mean, the process itself is going to be expanded, and other properties might be more relevant for the mining industry or the minerals processing. I'm thinking, for example, depending on your spatial location, water might be a big aspect, and just evaluating novel concepts, for example, novel solutions. You can easily both get the performance of the circuit, the performance of the units, as well as kind of the water consumption and the environmental impact in the end. So what needs to be quite clear here is that, for example, the environmental or the electrical consumption, that is always depending on where you are. So that needs to be quite flexible in order for it to be useful for minerals processing. We need to know the location of the site to have a good data set, select the right data set for the application.
So it's quite a complex system, but the simulator is there. So if I understand you right, we would need to add a couple of different production units, like in wet processing, flotation cells, if we talk flotation, and sumps and pumps, but that could be easily done if I understand you right.
I mean, we have full controllability of the solution itself, and it's quite flexible. I mean, it's coded in Python. So what we have at the moment, I have included some mill models and cyclones, and then I haven't looked into the flotation aspects of it. Of course, there's going to be new properties in the stream that we need to include, and then we might kind of reach more into the multi-component aspect, looking into mineralogy of the ore. But how the stream is designed is it's designed to be flexible. It's a variable size vector, basically, multidimensional variable space vector, variable size vector. So adding new aspects, it's kind of the purpose when it was purposely built.
Okay. I don't see any hands up.
I think Marcelo has a
Mr.
question.
Tavares has
Very
Marcelo.
nice. Hey, Gauti.
Oh.
I enjoyed a lot the presentation, and it's definitely nice to see that, as you know, a few years back, Juliana and I did work with environmental sensitivity analysis in a query here in Rio. But of course, back then, we used a mixture of IES, JKCNet, and also Excel, and of course, EcoInvent to get the impact. And of course, it was a lot of stitching back and forth. And we certainly appreciate that a platform like you guys have now, Bensmith, does make that life much easier. So really good to hear and nice to see the developments. And one question, I guess, is when you did that environmental sensitivity analysis of stationary crushing versus mobile. Of course, the issue of the diesel came to light, which is quite obvious that really is what you lose by doing that. But a few years back, we did a similar work, just looking at cost and opportunity. And looking at mobile systems, there's much more in the background as far as getting flexibility and reducing the time and the cost for trucks to go back and forth. So we did that for a long time, and it really required to look for many years to see the benefit of that, just in contrast to a stationary one, because of course the diesel is so overwhelming. But eventually, in some conditions, it turned out to be attractive in terms of costs. And I guess I suppose even that. So can you? My point to this is that some of the scenarios that when we look back into the mine require us to dig into really looking at outside our comfort zone into how really the operation can change, and that's of course in the earlier raw material stages. Can you comment on that? Because in the end of the day, some of the scenarios it's like a link that breaks into the weakest point. We kind of do a great job where we know exactly the nuts and bolts of crushing and screening, but sometimes when we go outside our zone, things get a little bit less confident when we actually try to look at scenarios. I'd like to hear a comment on that.
A good question. So when we are doing the estimation, we are usually doing the estimation on real-time data. That's looking on a historical data, what it has consumed over a given period. And we have seen that that's doing it over a year, don't really get data that you can use for process improvements. But if you start looking into in different months or weeks, then you can see that if you have certain changes in the operation, you can see the impact. And we have kind of gotten the question a couple of times, and we continue to getting it. Is that why even include a process simulation? Because all the data is based on historical data. And that's kind of the double purpose of the platform that I really didn't go into, is that one is to do the EPD and the LC report. That's kind of companies, if they're doing it for their products, they do it every 5th year or something like that. The other is to use that for process improvements. See, when I start tweaking my operation, when I start selecting, changing the CSS or aperture, what impact does that have on my production? And then what we do also is that we use the models to do suggestion for the allocation of the different resources on the different product groups. So the diesel consumption is quite interesting. It's what we need to look into a little bit more, and especially as you said, that the transport of the material, the logistics. I mean, the logistics are not included in the process simulator. So we cannot start playing around with different positions of the stockpiles and different pathway. That we cannot do. And I don't think that's kind of in the pipelines here anyway. So, but it's something that actually is the diesel consumption is the highest impact in most cases. So it is important, but not included.
Okay, thanks.
I think you're muted, Magnus.
Ah, sorry for that. Are there any other hands raised that I don't see? Well, if not, you have to speak up now. Otherwise, we are 15 minutes past the hour, so I think it's time to close the meeting. So thank you very much, Gauti.
Thank you,
I
guys.
hand
Thank
over
you,
back
Gauti.
to Tulio and
Yeah,
So-
thank you, Gauti, for the very interesting talk. And I'm sorry, my apologies for the
No,
inconvenience. But I'll have the recording in a few minutes, and I'll send it to you and to all the people that I have in the mailing list, so they will be able to at least to watch the presentation and to contact you to have some discussions or questions.
Thank you for the opportunity.
Yeah, thank you very much.
thank you, everyone. Bye.
Okay, thanks,
Bye.
everyone. Bye, fellas.